Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section I am going to discuss about the ionization energy topic students. It is the topic from first PUC 11th class. Lesson name classification of elements and periodic properties. Okay, nama thorough lesson. Right. Now what is ionization energy? Ionization energy. First of all, we are going to discuss about ionization energy definition. What is ionization energy? It is the minimum amount of energy is required. It is the See students, what is the definition? Ionization energy. It is the minimum amount of energy required to remove an electron from the valence shell of an isolated neutral gaseous atom. Here we are taking isolated individual atoms students. Okay, Nama? The atoms which are existing individually. And neutral. Neutral is nothing but having no charge. Are you clear? No charge. Gaseous atoms have to take none. Okay, na? So from the gaseous atom, isolated neutral gaseous atom, okay, from the valence shell, we have to remove the electron. So that means to remove the electron from the valence shell of an atom, how much energy is required? That is calling as ionization energy. Are you clear students? Are you clear? Now see here, suppose this is the atom, okay, this is the nucleus, this is the valence shell. Suppose here electron is there. To remove this electron, okay, how much energy we have to supply? That is calling as ionization energy. To remove this electron, suppose this is the valence shell. To remove this electron from the valence shell of an atom, okay, of an atom, how much energy is required? That is calling as ionization energy. Nana, are you clear? Ionization energy. Okay, now for this one I'm taking one example. See students, I'm taking here m gas. For example, I'm taking the neutral gaseous atom. Nana, neutral gaseous atom. Clear? So M is the neutral gaseous atom students. Neutral gaseous atom. Suppose it is having 6 protons. Suppose just example I'm taking. It is having 6 protons or 6 electrons. It is a neutral gaseous atom. Neutral. Neutral is nothing but here same number of protons and electrons. Protons number, electrons number should be same. Then we'll call it as it is a neutral atom. Are you clear? So here 6 protons, 6 electrons are there. Now from this from this atom students, okay, now by loss of electrons here, to remove the electron, here 6 protons, 6 electrons are there. So that's why whenever losing this electron, the M becomes M plus, and here one electron lost. Are you clear? One electron lost. That means here from these 6 electrons, to remove this one electron, how much energy is required? Okay, that energy will call it as first ionization energy. That is IE1. Are you clear? IE1. It is represented by ionization energy IE nana. It is the first ionization energy. That means what is first ionization energy? To remove the first electron. To remove the first electron, how much energy? Okay, energy, how much energy is required? How much energy required? That is calling as first ionization energy. Are you clear students? To remove the first electron, so from these 6 electrons, one electron it lost. To remove this electron, how much energy from this atom one electron lost? So that's why in M plus how many protons will be there students? 6 protons will be there. Protons number as it is. And coming to the electrons number students, coming to electrons number, how many electrons? Here one electron lost na, so that's why it is having 5 electrons. Are you clear? 6 protons and 5 electrons are present. Clear this students? To remove the first electron, how much energy required? That is calling as first ionization energy IE1. Okay, now from this M plus ion, now see, once you observe students, here M plus ion I'm taking M plus ion. So M plus ion is M plus ion, what are the protons and electrons students? 6 protons and 5 electrons. electrons are there. Now protons number is more, positive charge is more, protons number is more, protons are present in the nucleus, so that's why nuclear charge is more, so that's why nuclear attractions are more. Are you clear? So 6 protons, 5 electrons are less, electrons less, that's a protons number is more. So protons number is more means nuclear charge is more. Are you clear? Nuclear charge is more, nuclear charge more. So whenever nuclear charge more, then what will happen? Nuclear attractions are more. Clear students? Nuclear attractions are more on the valence electrons. Nuclear attractions are more on valence electrons. So whenever attractions are more, what will happen students? Nuclear attractions are more, so that's why nucleus is not ready to lose electron, not ready to lose valence electron, students. Okay, Nama. So that's why nucleus is not ready. Okay, nucleus is not ready to lose valence electron. Clear? Valence electron, it is not ready to lose valence electron, students. So that's why in this case we have to supply more energy to remove the valence electron. That means we have to supply more energy than the nuclear attractions. Are you clear? So then only the electron will come completely outside from the nuclear attractions from the valence shell. So that's why here 6 protons, 5 electrons, protons number is more, that means nuclear charge is more. Whenever nuclear charge more, nuclear attractions are more on the valence electrons. Understanding? So that means nucleus is not ready to lose valence electrons. Are you clear, students? So that's why here more energy is required. That means to remove the second electron, already one electron is removed from the atom. Now second electron we are removing from the atom. Are you clear? Second electron we are removing from the metal atom. Okay, so already this metal atom becomes M plus. That means here from 5 electrons, now we are removing the second electron. So here already one electron lost. Here next in 5 electrons, one electron losing. So that means it becomes M plus, gives rise to M plus 2, M plus 2 by loss of one electron. That means loss of one electron, M plus becomes M plus 2. Are you clear? From M plus one electron losing, one electron it is removing, students. So M plus means one electron lost. Well, again from this metal ion, from this ion, students. Okay, now from this ion another second electron removing. So that means here how many protons will be there, students? Here 6 protons, 5 electrons. Here 6 protons, so one electron lost now, so that's why here 4 electrons are present. Are you clear? So M plus 2 plus electron, that means M plus became M plus 2 by loss of one electron. So here to remove this electron, students, to remove this electron from the M plus ion, more energy is required because protons number is more. So that's why second ionization energy delta H value, IE2 value is more when compared to IE1. Understanding? Here because 6 protons, 6 electrons are there, so that's why here less energy is required to remove the electron. But when compared to this, here protons number more than electrons number, so that's why here nuclear attractions are more, so that's why to remove the electron from the valence shell of an atom, more energy is required. So IE2 is more. Are you clear? Now M plus 3 I am taking, generally see, students, M plus 3 I am taking. Now second equation, this is the first equation. Okay, now second over. Now third one, see, in third one, nana, here M plus 2 I am taking. So from M plus 2 removing third electron, so that means here removing the one more electron. Are you clear? So then it becomes M plus 3. Are you clear? So M plus 2 became M plus 3 by loss of one electron. So in M plus 2 how many protons are there? Actually how many protons there, students? 6 protons, so 4 electrons. 4 electrons. So from 4 electrons, 6 protons number is more, electrons number is very less. 4 electrons are here, 5 electrons there. Even 5 electrons there means 6 protons strongly attracting. Still electrons number is decreasing. That means protons attract, nuclear charge is more. Nuclear attractions are more because here 4 electrons only, the less number of electrons now. Are you clear? So whenever electrons number is less, protons number is more, then nuclear attractions are strong. Are you clear? So because electrons are less, so that's why nuclear charge more, nuclear attractions are more on the valence electrons. That's why nucleus is not ready to lose ready to lose valence electron. So in this case, students, m plus 3 means how many electron, how many protons? 6 protons. So how many electrons, students? 4 electrons, 1 electron lost. So that's it. Here it became 3 electrons. Are you clear? So total here 6 electrons are there in the metal atom. 1 electron here lost. Okay, 1 electron here lost. Second electron here lost. Third electron. To remove the first electron, energy is required, that is Ia1. To remove the second electron from the ion, it is very difficult to students, from the ion, because nuclear charge is more, protons number is more. Are you clear? So that's why Ia2 is more. To remove the second electron, how much energy is required? That is called second ionization energy. So here m plus 2, and m plus 2, from m plus 2 ion you have to remove the third electron, next electron. So that's why to remove the electron from the m plus 2 ion, it is very difficult. Understand? Because electrons are more, electrons are very less, protons are more. 6 protons, 6 protons attracting strongly the 4 electrons. So that's when nuclear attractions are more. Are you understanding? Here nuclear attractions are very strong, nuclear charge is more. Okay, nuclear charge is more here, nuclear charge more here is very more nuclear charge. So that's what will happen, students. Attractions are more on the valence electrons, nuclear attractions are more on the valence electrons. So that's why here more energy have to supply. Are you clear? Because protons, 6 protons, 4 electrons, so that means less electrons are very less. So that's why protons are strongly binding the electrons. Are you clear? Strongly binding the electrons, they are not ready to lose electrons, students. So that's why more energy is required to remove the electron from the valence shell of an atom. Here electrons are 5 only there, 6 protons, here 4 electrons, that means still electrons number is less. So that's why what will happen? Nuclear attractions are more. Okay, so that's why here delta H value, IE3, it is more. Are you clear? So when compared to this, here what we can say finally, IE3 is greater than, IE2 is greater than IE1. Understanding, students? That means third ionization energy. To remove the third electron from the m plus 2 ion, so to remove the third electron, this is third electron from the m plus 2 ion, it is very difficult because it lost 2 electrons. Okay, so m plus 2, so from this ion, to remove the electron is very difficult, students. Understanding? So because here m plus 2 is nothing but 6 protons, 4 electrons, electrons number is less, nuclear charge is more, nuclear attractions are very strong. So that's why not ready to lose electrons, so more energy is required. So that is generally we can say that IE3 is greater than, IE2 is greater than IE1. Understanding, amma? Now see, students, what are the factors affecting the ionization energy? So what are the factors affecting the ionization energy? So that factors, so what are the factors, see, students? Factors. So what are the factors? So first one, atomic size. So atomic size. Now see, students, atomic size is the one of the factor. So in atomic size, as the atomic size increases, as the atomic size, okay, atomic size increases, students, what will happen? Atomic size increases. Atomic size increases means small to big. Correct? Small to big. What will happen, students? As atomic size increases, that means small to big. Suppose this is small size and this is the big one. Atomic size is increases. Okay, then what will happen, students? Size increases the nucleus. This is the nucleus. Okay, now nucleus. So suppose here electron is present, here electron is there, here electron is there. Okay, to remove the here nuclear This is the valence shell. This is the valence shell. Here nuclear attractions are more on the valence electron. Here nuclear attractions are less because the distance between the nucleus and the valence electron or valence shell distance is less. Are you clear? Here distance is less, students. Here distance is more. Are you clear? Here distance is less. Here distance is more. Whenever distance is less, what will happen? Nuclear attractions are more. Clear this one. So here nuclear attractions are more. Understanding, students? Nuclear attractions more. So whenever nuclear attractions are more on the valence electron, it is ready to lose electron? No, it is not ready to lose electron. To remove this electron, students, we have to supply more energy. So that's why ionization energy is more. We have to supply more ionization energy. And coming to here, students, here distance is more between the nucleus and the valence electron. So that's why here nuclear attractions are less. Are you clear? Nuclear attractions less. Nuclear attractions less. So nuclear attractions less means attractions less, so that's why it is ready to lose electron. So that's why it is ready to lose electron. So that's why less energy is required to remove the electron from the valence shell. Very less energy is required because there is no nuclear attractions less. So that's why ionization energy is less. Are you clear in this case? So as the atomic size increases, students, what about ionization energy? It is here here more, here less. So that means from here to here, what is happening? Ionization energy increase, ionization energy decreases, students. Are you clear? As the atomic size increases, ionization energy decreases. Clear? Increases. Ionization energy decreases. Understanding, students? So one of the factor, atomic size is one of the factor. Okay now, so ionization energy depends on atomic size. As the atomic size increases, what will happen? Ionization energy decreases, students. Clear? Now coming to the nuclear charge, second factor, students. What is the second factor? Nuclear charge. Uh, Now see, students, as the nuclear charge increases, as the suppose nuclear charge is more. Nuclear charge is more means what, students? The attractions between the nucleus and the valence electron is more. Nuclear charge more. Nuclear charge more means what? Protons number is more than electrons number. So that's why nuclear attractions are strong on the valence electron. Whenever nuclear attractions are strong, what will happen? It is not ready to lose electron. So that's why more energy is required to remove the electron from the valence shell. That's why ionization energy is more. Are you clear? So ionization energy is more, students. Okay, now more the nuclear charge, more the nuclear charge. So nuclear charge is more means positive charge is more. That means protons number is more. Are you clear? Protons number is more than electrons. Understanding, students? Than electrons. So that's why more the nuclear charge, what will happen, students? More the nuclear charge, nuclear attractions are more. Nuclear attractions. Nuclear attractions are more on the valence electrons. Okay, nuclear attractions are very strong. Nuclear attractions are more means it is ready to lose electron? No, it is not ready to lose electron. Are you clear? It is not ready to lose electron because attractions are more. Are you clear? Attractions are more, so that's it is not ready to lose electron. So not ready to lose electron, so that's why here more energy is required. That means ionization energy is more in the case of nuclear charge. Are you clear, students? As the ionization energy increases, okay, the more the nuclear charge, what will happen? Protons number is more than the electrons. That means nuclear attractions are more on the valence electrons. It is not ready to lose electrons. More energy have to supply to remove the electron. That's why ionization energy is more, students. Now coming to the third factor, students, shielding effect. What is the third factor, Nana? Third factor is shielding effect. How shielding effect is how shielding effect, it is one of the factor of ionization energy, students. Third factor, shielding or screening effect. Okay, shielding effect. What is the shielding effect or screening effect, students? Screening effect. Here in this phenomena, students, here inner electrons acts as a screen or shield between the nucleus and the valence electron, students. Okay, now acts as a screen between the nucleus and the valence electrons. Okay, now so here now because of the inner electrons, what will happen, students? What will happen? Nuclear attractions decreases, students. That means it is reducing the nuclear charge. So that means inner electrons whenever acting as a screen or shield between the nucleus and the valence electrons, students. See, students, shielding effect. What is shielding effect, students? In this shielding effect, nana, inner electrons acts as a screen. Okay, na inner electrons acts as a screen. Okay, na screen or shield. Okay, nama screen or shield between the between the nuclei, between the nucleus and the valence electrons. Understanding, students? And the valence electrons. So because of these inner electrons, students, what will happen? These are acting as a screen between the nucleus and the valence electrons. But here what is happening, students? Because of these inner electrons, okay, now this atom is ready to lose the electrons. Are you clear? So it is ready to lose the electron. Are you clear, students? Ready to lose electrons because here nuclear attractions are decreasing. Are you clear? Because of inner electrons, nuclear charge is reducing. Okay, now because of these inner electrons, what will happen, students? Nuclear charge reduces. Okay, na reduces nuclear charge reduces. So that's why what is happening, students? What about the ionization energy? Nuclear charge reduces. That means inner electrons are unable to act as a screen between the nucleus and the valence electron. So that's why what will happen, students? Unable to inner electrons act. That means here inner electrons act as a screen between the nucleus and the valence electron. So what will happen, students? Because of that reason, okay, because of that reason, students, okay, what will happen, Nana? Inner electrons acts as a screen between the nucleus and the valence electron. So that's why these inner electrons are pushing the valence electrons. Okay, pushing the valence electrons away from the nucleus. So that's why what will happen, students? Nuclear attractions are decreases. Are you clear? Nuclear attractions decreases, students. Nuclear attractions decreases. So whenever nuclear attractions decreases, what will happen, students? Nuclear attractions when decreases, okay, then it is ready to lose the electron. Are you clear? It is ready to lose the electrons. It is ready to lose electrons. Clear this one? Ready to lose electrons. That means ionization energy, what will happen, students? Decreases. Ionization energy decreases. Okay, ionization energy decreases. Clear this, students? Ionization energy decreases. Once again, shielding effect. Inner electrons acts as a screen or shield between the nucleus and the valence electron, students. Whenever inner electrons acts as inner electrons is nothing but except valence electrons, remaining electrons are calling as inner electrons. Okay, now so generally nuclear attractions are more on the valence electrons, but here inner electrons are acting as a screen between the nucleus and the valence electrons. Because of this inner electronic attract, because of inner electrons act as a screen or shield between the nucleus and the valence electrons, what will happen, students? Because of these inner electrons, nuclear charge, what will happen, students? Nuclear charge decreases. Are you clear? So nuclear charge is decreasing. It is decreased. That means it is ready to lose. It is ready to lose electrons. Are you clear? It is ready to lose the electrons. See, students. So here nuclear charge decreases. That means nuclear attractions decreases on the valence electrons. Whenever attractions decreases, that means it is ready to lose the electrons. That means very less energy is required to remove the electrons. So that's why ionization energy decreases, students. Are you clear? So next one is fourth factor, students. What is the fourth factor? Fourth one. Fourth one is penetration power. Penetration power. So, what is the penetration power, students? So how it is affecting the ionization energy, penetration power? We know that here S electrons are very nearer to the nucleus, correct? So for example, this is the atom, students. This is the atom. Okay, this is the atom. So this is the first shell, second shell, third shell, fourth shell. Suppose this is the first shell. So in the first shell, how what are the subshells will be there? 1s subshell will be there. It is the second shell. In the second shell, 2s or 2p subshells will be there. That means s electrons are here. In the first shell, s electrons are there. In the second shell, p electrons there. In the third shell, d electrons. In the fourth shell, f electrons. Because first shell 1s, second shell 2 subshells, 2s, 2p. That means 2p electrons are present from the second shell, and the d electrons are present in the third shell, because third shell is having the 3 subshells, 3s, 3p, 3d. That means d electrons are present in the third shell, and f electrons are present in the fourth shell. Are you clear? That means which electrons are very nearer to the nucleus, students? S electrons are nearer. So that's why s electrons are the s electrons are strongly bounded by the nucleus. That means their penetration power is more. They're very fastly penetrated towards the nucleus, students. S electrons. Are you clear? So here s electrons will be there. Here p electrons. Here d electrons. Here f electrons. So that means s electrons are very near to the nucleus. Next p electrons. Next d electrons. Next f electrons. Are you clear? So that's a penetration power order. If you take s electrons, s greater than p greater than d greater than f. Okay. Now s electrons are very nearer to the nucleus. That means nuclear attractions are more on the s electrons. So from the s electrons we can remove the electron easily, students. We cannot remove, because nucleus is attracting very strongly this s electrons. So that's why here to remove the s electrons, very more ionization energy is required, students. So that's why here ionization energy order, if you take here, so what is the order, students? Same order you will get. That means s electrons, to remove the s electrons, more energy is required. Next, p electrons are bounded by the nucleus, so that's a nuclear attractions are more. So that's a here more energy is required to remove the electron, students. Are you clear? So in this order only, same ionization energy order will be there. So s is greater than, p is greater than, d is greater than f. Are you clear, students? This is about which one, students? Penetration power, penetration effect. Okay, nama. Next factor is completely or half filled electronic configuration. Completely or half filled electronic configuration. What is the next factor? Fifth one, completely filled, completely or half filled, completely or half filled electronic configuration. Now see, students, how it is affecting electronic configuration, how it is affecting the ionization energy. Now see, students, we know that completely filled and half filled electronic configurations are more stable, students. Electronic configurations are more stable. So that means it is very difficult to remove the electron, students, from the completely filled and half filled electronic configurations. To remove the electron, more ionization energy is required, students. Are you clear? To remove the electron, more energy is required. So that's why here it is very difficult to remove the electron, more ionization energy is required. Are you clear? So completely filled and half filled. Okay, completely filled and half filled electronic configurations are more stable, students. Electronic configurations are more stable. Are you clear? So these electronic configurations are more. Now see, students, completely filled and half filled electronic configurations are more stable. Okay, so from this electronic configuration, if you want to remove the electron, more energy is required. It is very difficult to remove the electron, students. That means they are stable is nothing but those electrons are strongly bounded by the nucleus. Are you clear? So here more energy is required. Are you understanding, students? Here more energy is required. So that's why here ionization energy is more. Understanding? It is very difficult to remove the electron. It is very difficult to remove the electron, to remove an electron from the electron from the stable electronic configurations, clear? So that's why here ionization energy is more. Are you clear, students? Ionization energy is more. Okay, so for example, I am taking nitrogen and oxygen, students. I am taking one example, Nana, nitrogen and oxygen. See here, nitrogen and oxygen. I want to find IE1. That means IE1 is nothing but to remove the first electron from the valence shell. How much energy is required? That is IE1, students. Okay, na? So I want to find IE1 value. Okay. IE1. Nitrogen, for example, I am taking nitrogen. So, nitrogen atomic number is 7. Electronic configuration 1s2, 2s2, 2p3, 2s2, 2p3. Clear? So, that means in the valence shell, how many valence electrons are there? 5 valence electrons are there. Now, here in 2s, 2 electrons are there. In 2p, how many electrons are there? 3 are there. 1, 2, 3. That means 2p, in 2p subshell, 3 electrons are there. Now see students, 2s is completely filled, 2p is half filled. So that's why half filled and completely filled orbitals are more stable. So that's why it is a stable electronic configuration. From this electronic configuration stable, okay, now to remove the valence electron, more energy is required, students. Are you clear? So that means IE1 of nitrogen is more. Now oxygen, see, once you check oxygen atomic number is 8. That means what is the electronic configuration? 1s2, 2s2, 2p4. That means in the 2s, 2 electrons. In 2p, how many? 4 electrons are there. Total 4 electrons. It is stable. It is not half filled, not completely filled. Are you clear, students? Half filled means what, students? In each orbital, single electron should be there. Then we'll call it as half filled. Okay, Rama? Now see here, I am writing this is half filled. Means each orbital is filled with 1 electron. We'll call it as half filled. Okay, half filled. And here, if suppose 3 orbitals are filled with 2 electrons, it is a completely filled. Are you clear? It is a completely filled. Nana. Are you clear? Okay, so it is a completely filled. Now this is, see, it is half filled. No. It is completely filled. No. So it is not half filled, completely filled. That's why it is not a stable. Are you clear? It is unstable. So that's why here from this we can remove the electron, students. That means ionization energy in the case of oxygen, IE1 of oxygen is less. Okay, now to remove, we can easily remove the electron, students. But in this case, it is having the stable electronic configuration. So that's why here IE1, here what we can write finally, IE1 of nitrogen is greater than IE1 of oxygen. Are you clear? Understanding, students? So nitrogen is having the stable electronic configuration, so that's why to remove the electron it is very difficult. More energy is required. IE1 is more, greater than IE1 of oxygen. Now I want to calculate IE2, students. Okay, now IE2, I have to find IE2 value of nitrogen and oxygen. In IE1, here in IE1, students, nitrogen lost already 1 electron. Are you clear? So by loss of 1 electron, what is its electronic configuration? In IE1, nitrogen electronic configuration is 6. That means 1 electron lost. That means 1s2, 2s2, 2p2 only. 2s means how much, Nana? 2s. 2s means 2 electrons. In 2p, how many electrons are there? 2 electrons only there. Before 3 are there. In IE1, first 1 electron is lost. So because of loss of electron, it becomes 2p2 only it is having. Now it is unstable. Are you clear? It is unstable, students. Unstable. Okay. Now take oxygen, students. Oxygen atomic number is 8 here. That means in the IE1, it is lost 1 electron. Okay, na? So that's why whenever lost electron, a oxygen atomic number 7. Oxygen is 8, na? 1 electron lost, na? So that's why 7. Then 1s2, 2s2, 2p3. Before, it is having the 2p4 electronic configuration. By loss of one electron, 2p3, it became 2p3. Are you clear? 2p3, that means 2s2, this is 2 electrons, now 2p3, here 3 electrons. Now see this electronic configuration. By loss of one electron, oxygen will get stable electronic configuration. Okay. Now from this stable electronic configuration, to remove the electron is very difficult. So that's why IE2 is more. IE2 is more. Here IE2 is less. So that's why finally we can say IE2 of IE2. Okay. IE2 of oxygen is more than IE2 of nitrogen. Understanding, students? Clear this one. Okay, IE1 of oxygen. Understanding, amma? Nitrogen IE1 is IE1 of nitrogen is more. Here IE1 of IE2 of oxygen is more. Clear? In the IE1 of nitrogen, nitrogen is having the stable electronic configuration. That's why to remove the electron very difficult, more energy is required. That's why nitrogen is more. Now after loss of one electron, uh, nitrogen electronic configuration will become 1s2, 2s2, 2p2. Before 2p3, now it is becoming 2p3, now it is became 2p2. Oxygen 8, 2s to 2p4, now it became 2p3, because in the IE1 it lost one electron, na? So that's why after loss of electron, oxygen will get stable electronic configuration. So that's why IE2 is more in the case of oxygen than nitrogen. Are you clear, students? And one more factor is there, that is a net charge on the atom. Net charge on the atom, student. That is the sixth factor. Now we are going to discuss. What is the sixth factor? Now see, Nana, sixth one. Sixth factor, net charge on the atom. Net charge on the atom. So what is the net charge on the atom, students? Now see here, net charge on the atom. For example, I am taking, whenever net charge on the atom increases, students, automatically ionization energy also increases. So that means we can say that net charge on the atom is directly proportional to the ionization energy. For example, I am taking Al plus 2, Al plus 3. Now charge on atom increases, plus 1, plus 2, plus 3. Charge on atom increases, ionization energy also increases, students. Okay, Nama? Ionization energy also increases. So that's why what is the order? This one increases. How, madam? How it is increases charge on atom? See here. Here 1 electron lost. Here 2 electrons lost. Here 3 electrons lost. Are you clear? Aluminium means here atomic number how much, Nana? 13, no? Protons. So 13 protons. Atomic number 13, no? 13 protons. So 12 electrons. Here 13 protons, 2 electrons lost. Means 11 electrons. Here 13 protons, 3 electrons lost. That means here 10 electrons are there. So protons number is more when compared to electrons. Here electrons number where it is less, here less. So that's why this size is small. Okay. Next 11 electrons, this one. Next this is 12 electrons, its size is more. Are you clear? Understanding, students? So whenever charge is more, that size is small, students. That means it lost 3 electrons, that's why size is very small. It lost 2 electrons, its size is small. It lost only 1 electron, that's its size is more. Clear this one? Understanding, students? Okay, number plus 1, plus 2, plus 3. So more charge is there, that means more charge there, that means size is small. Are you clear? So 3 electrons lost, that's it, size is very small. Are you clear? Understanding, students? Okay, 3, it is lost 3 electrons, that's its size is small. Whenever size is small, attractions are more, nuclear attractions are more on the electrons. So that's why ionization energy is more in this case. Are you clear? So that's why what I told you, net charge on an atom is increases, ionization energy, it is directly proportional. So that means what we can say, charge on the atom. So net charge on the atom on the atom increases, net charge on the atom increases, students, ionization energy also increases. Clear this one, ionization energy also increases, students. Okay nama. So these are the factors affecting the ionization energy topic nana. Ionization energy. I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Okay, thank you very much, students.